A flicker in the solar fire, the discovery and the perihelion anomaly. On October 27, 2025, as the sun blazed in its mid-autumn fury, a silent intruder slipped through the inner solar system, closer to our star than Mercury, hotter than molten lead, yet refusing to behave like anything astronomers had ever seen. This was 3I/ATLAS, the third confirmed interstellar object to visit our cosmic neighborhood. But unlike Oumuamua's ghostly silence or Borisov's familiar coma, 3I/ATLAS did something unprecedented. It lit up like a beacon of defiance. NASA's Punch satellite constellation captured the moment. So did SOHO and STEREO. And what they saw wasn't just unusual, it was impossible by conventional comet standards. As the object neared perihelion, the closest point to the sun, its brightness surged not with the expected inverse square law, but with a staggering inverse seventh power dependence on solar distance. In plain terms, for every halving of its distance to the sun, it didn't just get 4 times brighter, it got over 180 times brighter. No known comet in the Oort cloud, Kuiper belt, or any catalogued archive has ever exhibited such behavior. This wasn't sublimation. This was something else, something reactive, responsive, almost alive in its interaction with stellar energy. And then, it vanished behind the sun, but not before leaving a trail of questions that would shake the foundations of planetary science. When nature violates expectation, it's not chaos. It's revelation. The ghost from Sagittarius, origins, trajectory, and the wow signal connection. 3I/ATLAS didn't just appear. It announced itself on a path written in celestial code. Tracing its hyperbolic orbit backward through time, astronomers pinpointed its origin. The constellation Sagittarius, the same patch of sky that, in 1977, transmitted the legendary WOW signal, a 72-second burst of narrowband radio energy so intense and anomalous that it remains unexplained to this day. Coincidence? Probably. But in the world of interstellar visitors, coincidences demand scrutiny. Unlike Oumuamua, which tumbled erratically through space, 3I/ATLAS followed a near-perfect hyperbolic arc, indicating it had never been gravitationally bound to any star. It was a true vagabond, ejected from a distant planetary system, perhaps billions of years ago, drifting across the interstellar void until our sun's gravity gently plucked it from the dark. Its speed? Over 60 kilometers per second relative to the sun, fast enough to escape the Milky Way's gravitational well entirely. But here's the twist. Its approach wasn't random. The trajectory suggested it may have been subtly aimed by gravitational lensing from unseen masses, or perhaps, though scientists hesitate to say it, by something more intentional. As it passed Mars on October 2, 2025, just 30 million kilometers away, the Mars Reconnaissance Orbiter, MRO, locked on. Its high-rise camera, capable of resolving objects just 30 centimeters across from orbit, snapped a series of high-resolution images. But then, silence. A U.S. government shutdown froze NASA's data pipeline. The images were never released. Rumors spread. What did they see? The blue anomaly, spectral shock, and the color that shouldn't exist. While 3I/ATLAS hid behind the sun, astronomers turned to coronagraphs, telescopes that block the sun's glare to reveal hidden objects. Using color filters on SOHO and STEREO, they analyzed its reflected light, and what they found defied all logic. 3I/ATLAS appeared bluer than the sun itself. Now, the sun's photosphere glows at about 5,800 Kelvin, yellow-white to human eyes, with a balanced spectrum peaking in green-yellow. Any cold object reflecting sunlight, like a comet or asteroid, should appear redder, not bluer. Dust scatters red light more efficiently. Ices absorb blue. Even fresh ice on Europa looks pale gray, not azure. Yet 3I/ATLAS spectrum was skewed toward shorter wavelengths, suggesting either it was emitting its own light, like a thermal or even non-thermal radiation source hotter than the solar surface, or its surface was composed of exotic materials that preferentially reflect or scatter blue light, a phenomenon never observed in natural solar system bodies. Harvard astronomer Avi Loeb, who famously proposed Oumuamua could be artificial, called this one of the most puzzling optical properties ever recorded. If this object is natural, Loeb said in a private seminar leaked to the Astronomers Telegram, then our models of interstellar chemistry are missing something fundamental. If it's not, then we must ask, what is it powered by? A power source hotter than the sun in a 500-meter object? The implications were staggering. The push that wasn't gravity, non-gravitational acceleration, and the outgassing debate. Then came the second shock. Precise astrometric tracking revealed that 3I/ATLAS wasn't following a purely gravitational path. As it rounded the sun, it experienced a tiny but measurable acceleration, 3 × 10 to the -14th to 2 × 10 to the -10th astronomical units per day squared. Too small for casual observation, but unmistakable in orbital models. This is non-gravitational acceleration, a phenomenon seen in comets when volatile ices sublimate, releasing gas that acts like a natural thruster. But here's the problem. The acceleration didn't match the expected outgassing profile. For a typical comet, acceleration correlates with brightness and gas production. Yet 3I/ATLAS acceleration began before significant brightness spikes and persisted in a direction that didn't align with its apparent rotation or dust jets. David DeFaria, a navigation engineer at NASA's Jet Propulsion Laboratory, noted, "The vector of the acceleration is misaligned with the solar anti-direction by over 20 degrees. That's like a sailboat tacking against the wind, not impossible, but highly unusual for a tumbling ice ball." If this isn't outgassing, what is it? Speculation ran wild. Could it be radiation pressure on an ultra-thin structure, like a light sail? Magnetic interactions with the solar wind? Or something entirely new, a propulsion mechanism unknown to current physics? The chemical onion, layered composition, and the nickel mystery. When 3I/ATLAS reemerged from solar conjunction, spectroscopic observations revealed a multi-layered coma unlike any comet ever studied. Innermost layer, dominated by nickel vapor, with almost no iron. Middle layer, rich in cyanide compounds, CN, toxic, volatile, and rare in such concentrations. Outer envelope, flooding with carbon monoxide, CO, and carbon dioxide, CO2, typical for comets, but here in extreme abundance. This chemical stratification suggested extreme thermal differentiation, as if the object had been baked, frozen, and reprocessed in multiple stellar environments. But nickel without iron? That's geochemically bizarre. In our solar system, nickel and iron are siblings, born together in supernovae, condensed together in planetesimals. To find one without the other implies formation in a metal-poor, oxygen-rich nebula or artificial refinement. And cyanide? While comets like Hale-Bopp show CN, the intensity and persistence in 3I/ATLAS hinted at a reservoir far deeper than surface ice. "It's as if this object has an internal engine," said Dr. Lena Petrova of the European Southern Observatory. Not just passive sublimation, but active, layered degassing from distinct reservoirs.